Imagine the Roman world at its zenith, bustling cities, legions marching in formation, and merchants carrying goods from one distant province to another. Beneath this vibrant tapestry lay something just as remarkable as Rome's armies or Senate chambers, an intricate network of roads and aqueducts, the silent arteries and lifeblood of the empire. These feats of engineering were not merely practical solutions. They were deliberate statements of power, unity, and vision investments that made Rome not just a city, but a civilization capable of enduring and expanding. The Romans understood early on that the vastness of their ambitions required more than military might. Conquest alone could not knit together the far-flung territory stretching from Britain's misty frontiers to the deserts of Syria. Reliable infrastructure built to last and on a scale never before attempted became an unspoken promise of security, prosperity, and connection. From the first stones of the Appian Way, laid in 312 before Christ, to the soaring arches of aqueducts feeding Rome itself, the empire's backbone was formed not only by legions, but also by laborers, engineers, and visionaries who saw roads and water as instruments of both conquest and civilization. The motivations behind this unprecedented investment were as varied as the empire itself. For the military, the logic was clear. Armies needed to move swiftly across great distances, responding to threats or rebellions with a speed that could mean the difference between victory and disaster. Roads were built, first and foremost, for the legions. They ran arrows straight across valleys and hills, constructed in durable layers with drainage ditches and raised embankments, features designed to withstand both weather and the pounding feet of thousands of marching men. The Appian Way, originally stretching 132 Roman miles, set the pattern that would be repeated across the empire, robust, direct, and engineered for efficiency. But military necessity soon gave way to broader ambitions. As Rome's city swelled with people, Rome itself eventually housing, scholars estimate, over 1 million inhabitants, the demand for reliable supplies, communication, and economic integration became ever more urgent. Roads, totaling an astonishing approximately 80,000 kilometers, about 50,000 miles, at the empire's height, became the veins through which goods, information, and people flowed. They tied distant provinces to the capital, reducing transport costs and binding regional markets into a single, integrated economic system. Infrastructure, in this sense, was not just a convenience, it was a force for unity, administration, and prosperity. Nowhere was this more apparent than in the provision of water. In Rome, access to fresh, clean water became nothing less than a civil right. The city's population, by far the largest in the ancient world, required a steady and abundant supply. Scholarly estimates typically range between 200 and 300 liters per person each day. Meeting this need demanded solutions of breathtaking ingenuity. Romans drew upon the knowledge of earlier civilizations, the Greeks, Etruscans, Egyptians, and Babylonians, refining and expanding their techniques to suit the scale of their needs. The result was a system of aqueducts that Pliny the Elder would later praise as Rome's greatest marvel. Aqueducts like the Aqua Appia, begun in 312 before Christ, and the Aqua Virgo, completed in 19 before the Common Era, carried water from springs as far as 92 kilometers away, guided by the unerring logic of gravity. Most of their courses ran underground, but where valleys intervened, the Romans raised majestic arched bridges, structures that still inspire awe today. The Aqueduct of Claudius, constructed between 38 and 52 Anno Domini, stretched approximately 69 kilometers, 43 miles to supply the city. Altogether, 11 major aqueducts fed Rome, their careful gradients a testament to the skill and precision of Roman surveyors and engineers. Even now, evidence of their work endures. The Aqua Virgo, after more than 2 millennia, still delivers water to parts of modern Rome. Behind these achievements stood not only emperors and visionaries, Augustus, Caligula, Claudius, Trajan, but also a tradition of engineering philosophy captured in the writings of figures like Vitruvius and the meticulous records of water commissioners such as Sextus Julius Frontinus. Their work reflected an ethos that saw infrastructure as an expression of civic pride and imperial grandeur. Cities throughout the empire strove to emulate Rome's example, constructing their own networks of roads and aqueducts, each a symbol of their place within the imperial order. The societal impact of all this was profound. Infrastructure underpinned urbanization, allowing cities to grow larger, healthier, and more interconnected than ever before. It enabled economic expansion by making trade easier and more reliable, and it facilitated the administration of distant provinces, tying them ever more tightly into the fabric of Roman governance. The Roman army itself played a direct role, not only in building but also in maintaining these vital systems, especially in times of peace. Yet, for all their scale and sophistication, these achievements also invite questions. The sources tell us little about the financing and organization of labor behind such monumental projects. Whether they relied primarily on slaves, soldiers, or paid workers remains a subject for further inquiry. Nor do they speak in detail to the ways infrastructure shaped cities outside Rome, or to the challenges of maintenance and eventual decline. What is clear, however, is that the vision and necessity that drove Rome's investment in infrastructure left a legacy that far outlasted the empire itself. The roads and aqueducts, enduring in both stone and memory, stand as silent witnesses to an age that understood, perhaps better than any before it, the power of engineering to shape the destiny of nations. To appreciate the true magnitude of Rome's achievement, one must envision the empire not just as a collection of cities and provinces, but as a living web of stone and water, binding together diverse peoples and landscapes. This web, woven from roads that cut straight through forests and mountains, and aqueducts that carried pure water over valleys and plains, stands as a testament to the technical brilliance and organizational might of Roman engineering. At the heart of Roman road building was an unwavering pursuit of directness and durability. Surveyors equipped with tools such as the groma set out to draw straight lines across the untamed countryside. When faced with obstacles, marshes, hills, or dense forests, the Romans rarely yielded. Roads like the Appian Way, begun in 312 before Christ under the oversight of Appius Claudius Caecus, exemplified this determination. Rather than winding around barriers, engineers devised methods to cut through them, reflecting a mindset in which control over the landscape was both a practical necessity and a statement of imperial ambition. The construction process itself revealed a meticulous approach to problem solving. Roman roads were more than simple stone paths. They were complex, layered structures engineered for resilience. Builders began by excavating a deep roadbed to ensure a stable foundation. Over this, they laid a base of large stones, followed by successive layers of gravel and sand, each compacted for maximum solidity. The top layer consisted of tightly fitted paving stones, their surfaces gently cambered to shed rainwater toward roadside ditches. This attention to drainage was crucial, as water is the perennial enemy of roads. Through such stratified construction and careful engineering, Roman roads could withstand the passage of legions, supply wagons, and the relentless march of centuries. Roman concrete played a central role in this durability. By blending locally sourced stone, lime, and volcanic ash, the Romans produced a material that resisted both the pressures of traffic and the erosive forces of weather. This innovation contributed not only to the longevity of the roads, but also to the monumental scale of aqueducts, where strength and stability were paramount. The empire's network of roads eventually stretched some 400,000 kilometers, about 250,000 miles, with approximately 80,500 kilometers paved, crossing mountains, plains, and rivers. These arteries were essential for military logistics, enabling troops and messengers to traverse the empire with unprecedented speed. Yet their impact extended far beyond the movement of armies. Roads linked towns to markets, citizens to civic centers, and distant provinces to the heart of Rome itself. The very straightness of these roads spoke to Roman priorities, directness, order, and the imposition of will upon a vast and varied world. If roads brought cohesion to the empire, aqueducts brought life to its cities. The first of these marvels, the Aqua Appia, was constructed in 312 before Christ, a project that, like the Appian Way, bore the mark of Appius Claudius Caecus. Over the next several centuries, aqueducts became the veins and arteries of Roman urban existence, supplying water for public baths, fountains, private households, and even supporting specialized industries such as milling and agriculture. The technical challenge of aqueduct construction lay in maintaining a steady, gentle gradient, enough to let gravity carry water across tens of miles, but not so steep as to cause destructive torrents. Roman engineers relied on a suite of surveying instruments, the groma for straight lines, the dioptra for measuring angles, and the chorobates, a sophisticated leveling device used to ensure the precise slope needed for water to flow smoothly. Most aqueducts ran unseen beneath the earth, shielded from contamination and damage. But where valleys or ravines intervened, Roman builders raised monumental arcades, like the celebrated Pont du Gard in Gaul, their soaring arches a marriage of utility and grandeur. Within Rome itself, the scale of this undertaking is difficult to overstate. By the 3rd century AD, 11 major aqueducts supplied a metropolis of over 1 million people. The Aqua Claudia, completed in 52 AD, was among the largest, stretching about 69 kilometers and delivering water at a rate of approximately 2.3 cubic meters per second. Systems of sedimentation tanks, sluices, and distribution reservoirs regulated the flow, filtered debris, and apportioned water to the city's districts. It is estimated that the water supply reached nearly 900 liters per person each day, a figure that underscores both the ambition and the practical mastery of Roman hydraulic engineering. The materials chosen for these feats were as carefully considered as their designs. Builders used stone, brick, and above all, Roman concrete, each selected for strength, availability, and suitability to the local environment. The graceful arches of aqueduct bridges were more than aesthetic flourishes. They distributed weight efficiently and allowed the structures to span wide valleys without collapse, ensuring both stability and a distinctive silhouette on the landscape. Behind these marvels lay an ethos extolled by Roman thinkers such as Vitruvius, a commitment to utility, durability, and the conquest of natural obstacles. The genius of Roman engineering was not just in technical know-how, but in organization, the ability to coordinate resources, labor, and expertise across vast distances and under demanding conditions. While the specifics of workforce organization or maintenance routines are not fully illuminated by surviving records, the sheer scale and endurance of these projects suggest a disciplined and methodical approach. Today, the legacy of Roman engineering endures, visible in the remnants of ancient roads and the persistent trickle of aqueducts like the Aqua Virgo, which still feeds Rome's fountains. These structures are more than relics. They are monuments to a civilization that viewed infrastructure as the backbone of empire, an enduring testament to human ingenuity, ambition, and the relentless pursuit of mastery over land and water. There is a certain paradox at the heart of Rome's enduring legacy. The empire that once seemed to dominate the ancient world through sheer force has, over 2 millennia, proved most influential not through conquest, but through construction. The roads, aqueducts, and ingenious materials of Roman infrastructure continue to shape the very fabric of cities around the globe. Even as the empire itself receded into history, the physical traces of its ambition persisted, lines etched across landscapes, arches spanning rivers, and domes rising above bustling urban centers. What is it about these ancient feats of engineering that allowed them not merely to survive, but to become the blueprint for so much that followed? The answer begins with the Roman idea of infrastructure as a public good, an inheritance not only for Romans, but for all who would later inhabit the spaces they transformed. Their road network, for example, was both vast and remarkably resilient. At its peak, this web of connectivity stretched over 400,000 kilometers, with more than 80,500 of those paved in stone. Some sources provide lower estimates, but the figure of over 400,000 kilometers is widely cited. Roman engineers did not shy away from the challenges of geography. Rather than skirting obstacles, they confronted them directly, piercing mountains with tunnels and spanning gorges with bridges. The first of these great projects, the Appian Way, was already an ambitious undertaking when it began in 312 before Christ under the direction of Appius Claudius Caecus. Stretching 132 miles from Rome to Brindisi, its straight and purposeful path set the standard for all that would follow. What set these roads apart was not simply their scale, but the meticulous methods used in their construction. Multiple layers, crushed stone, mortar, sand, and tightly fitted pavers gave them a strength and durability that modern highways often struggle to match. They were sloped with careful attention to drainage, designed to withstand floods and seasonal torrents. These roads were arteries of empire, certainly, but they were also channels along which commerce, ideas, and populations flowed. Cities and markets clustered along their edges, creating a pattern of economic concentration that remains visible in the urban geography of Europe and beyond. In a sense, to travel today along certain highways in Italy, France, or Britain is to trace the very footsteps of Roman surveyors. Many modern roads still follow their ancient routes, and in some places, the original stones bear the weight of 21st century travelers. Yet the genius of Roman infrastructure was not limited to the land. The empire's aqueducts were marvels of hydraulic engineering, supplying cities with fresh water on a scale that few ancient societies could match. The earliest, the Aqua Appia, was constructed in the same year as the Appian Way, a testament to Rome's coordinated vision for connectivity and urban life. By the height of the empire, Rome alone boasted 11 aqueduct systems, some drawing water from sources as distant as 92 kilometers away. These networks relied on the principle of gravity, their gradients calculated with striking precision. Water was carried in a combination of underground pipes, stone canals, and soaring arcades, structures that, in some instances, have remained functional for over 2,000 years. The Aqua Virgo, for example, still feeds Rome's iconic Trevi fountain. The impact of these aqueducts was transformative. They enabled the proliferation of public baths, fountains, and sanitation systems, underpinning the health and vibrancy of Roman urban life. At their zenith, the aqueducts supplied up to 300 million gallons of water each day, levels of per capita consumption rivaling those of modern New York City. The principles that guided their construction, careful surveying, redundancy, and public accessibility, continue to inform the design of urban water systems today. Equally impressive, though perhaps less visible to the casual observer, was the Roman mastery of materials, most notably their invention of a concrete that has stood the test of centuries. By blending volcanic ash and lime, Roman builders created a substance with remarkable strength and resilience. Modern researchers have found that this ancient concrete possessed self-healing properties, the result of hot mixing techniques and the inclusion of quicklime. When cracks developed, the material could effectively repair itself, sealing fissures and preserving the integrity of the structure. This innovation has allowed the Pantheon, with its massive unreinforced dome, and the Colosseum's iconic arches to endure through centuries of earthquakes, weather, and human activity. The influence of these engineering feats radiates far beyond the ruins themselves. Roman standards of durability and efficiency became the benchmarks for road and water system construction in later societies. The very concept of public infrastructure, roads, aqueducts, sewers as shared assets essential to civic life, was first articulated and realized on this grand scale by Rome. As cities from Chicago to Florence took shape, architects and planners drew inspiration from Roman precedents, borrowing not only the visual language of arches and domes, but also the underlying principles of connectivity, accessibility, and resilience. It is difficult to overstate the persistence of these ancient ideas. In many modern cities, the outlines of Roman planning are still discernible, not only in street patterns but in the very logic of urban organization. Civil engineers continue to study Roman methods, seeking to emulate the balance of utility and beauty, strength and adaptability that characterize their work. The ongoing fascination with Roman concrete, in particular, speaks to a modern yearning for materials that can endure as theirs have done. Of course, there are aspects of this legacy that remain less well understood. How exactly were such vast systems maintained over the centuries following Rome's decline? What were the broader social and environmental consequences of reshaping landscapes on such a scale? The evidence is incomplete, and scholars continue to debate the full impact of Rome's infrastructural inheritance on societies that rose in the empire's wake. But there can be little doubt that the foundation Rome laid, quite literally, has shaped not only the cities we inhabit, but the very ways in which we conceive of public works and communal life. As one walks the ancient stones of a Roman road or stands in the cool shadow of an aqueduct's arcade, the past feels at once distant and immediate. The empire that built them has faded into history, but its vision endures, etched into the bones of our cities, flowing through pipes and channels, guiding the routes we travel and the water we drink. In this way, Rome's greatest conquest was not of territory, but of time itself.